So yeah, I'm Glenn. This is Darren. Um, I
Hi.
don't, I don't know if I gesture this way. Is he on my right side? But sure. So we're going to run you through Deep Racer 101. Basically, we're just going to take you through making your first model. It is like a follow along workshop if you want it to be. So if it is something you're wanting to do, just make sure to sign up for an AWS account if you haven't got one already. It should take about 2 to 3 minutes. You'll need a debit card to sign up, but everything we'll be doing in this workshop will be free or covered within free tier. But we'll talk on that a little bit in a second. And yeah, without further ado, let's get stuck in. So just going to run through a little bit about who we are, why we're teaching you about Deep Racer, run through how the workshop's going to work. We'll run through your first model and cover all the key things that you need to know about training a Deep Racer model. And then we're going to run through actually evaluating your model as well to see if it's any good. So I suppose the first question is, who are we? So we're each senior software developers at Liberty IT in Belfast. We actually had an internal league in Liberty between Liberty IT and Liberty Mutual. So Liberty Mutual is a huge company. There were like hundreds of people entered this. And the winners of this competition got to go over to reInvent, which is the big Amazon Web Services conference for the year, to race in the World Championships in Las Vegas, which was really incredible. From that, we finished fourth in the world, which is a pretty respectable place to finish. And we've actually each managed to get into the finals for this year again. So we're hoping to even do better than that fourth this time around. And between us, we've put way too much time into Deep Racer. So we're fairly versed up on how it all works. We actually, if you're familiar with Deep Racer at all, or if you've watched any of the Deep Racer TV stuff on Amazon, we actually featured on the last episode of it. So you can see these are pretty popular. You're talking like coming up to 250,000 views. If you are wanting to get into Deep Racer, I'd really recommend these. They're done in like a kind of fun esports way. They're genuinely quite entertaining and very informative as well. So how the workshop's going to work, it takes roughly about 15 minutes minimum to actually train a model that will be able to get around the track in any way. Because it takes a lot of resources to actually do machine learning, it takes about 10 minutes either side to actually spin up those resources and then shut them down again, after which you'll be able to evaluate your model. So because we're fairly limited for time, what we're going to do is like fly through the setup. If you want to follow along, it's all very basic, kind of all done within the console. It's just a case of like clicking a lot of buttons, really. We're going to fly through that. A lot of it won't really make sense, but then while the model's training, we're going to go back and explain what each of those parameters that we told you about was. There is a big warning. Deep Racer is really expensive. If you're wanting to train a model just with your own cash, you're talking like $3.50 an hour to actually train your model. And this really adds up very quickly because you're talking, for some of the models, you're talking maybe 8 to 10 hours, depending on what you're trying to accomplish. And after that 8 to 10 hours, if the model isn't any good, which you won't find out really till afterwards, then you have to do it all again. And it very quickly adds up. Luckily, when you first sign up with AWS, you should be in their free tier for a year. And as part of free tier, you get 10 free hours of AWS training, of Deep Racer training. So what we'll be doing today is easily covered within that. As I say, we're just doing like a 15-minute model. And after the fact, just really do keep a close eye on your costs. And that's it for the introduction. I'm going to switch over to Darren now to run you through the actual console and the workshop itself.
Cool, thanks, Glenn. I'm just doing a screen share, so you'll keep an eye on the chat for me then. And,
yeah, I will indeed.
Let's see.
Yeah, I need to stop sharing.
Possibly, I think I need to Firefox. Yeah, I'll just get it over with now. Back in a sec.
No worries. So luckily, I've prepared some slides just for this occasion. So I'll skip to the end. So yeah, I put some slides in to kind of talk about the actual World Championships, just to give you an idea about the atmosphere. like it was incredible. As I mentioned, it was in Vegas, so a lot of the stuff happened in these big, like this is the MGM Grand Arena. So a lot of the stuff just felt really, really like it was this really big occasion. You can see there they've got 6 tracks set up, so there was always some sort of racing going on for people to spectate. At the very back there, you've got the commentators booth. Again, this was very much for like the Deep Racer TV side of things. So the atmosphere was incredible. There were live scoreboards as well, so you can see there at the end of the warm-ups, we'd set like the second fastest time out of the 64 people there. So it was definitely something worth celebrating. And you can see again, there's some of the interviews taking place as again for Deep Racer TV. Again, more interviews. So the whole thing was really, really good fun. As I say, I would really recommend Deep Racer TV just as something to kind of whet your appetite for the whole, for lack of a better word, the whole sport.
Anything sharing for you, Glenn? Is it
yeah,
the
it is.
console?
Yep. I'll just switch over to that now.
Sorry, folks. Yeah, just Firefox. Haven't ever used this program before. So if you're looking to follow along, we'll go through it real quick, as Glenn says, and then we'll talk more about why that's happening. So in your AWS management console, you can just search for Deep, and you should see Deep Racer as your third option down. So give that a click. A similar screen, and what we want to do first is open up our garage. So you can new tab, click that, and we want to build a new vehicle. So the options we have here, just keep them all default. We're using a single camera, and as well, Glenn, if anyone's asking for me to go back, you can just give me a wee shout.
Yeah, no worries. Maybe if you go just a little slower between screens. I think there's a little bit of lag just on our end.
Yeah, I'll hang here for a second. Sorry. So
yeah, no worries.
Down the side at your garage, build a new vehicle. Keep it on the single camera, and then we'll click next. And then from here, you want your fourth drop down, just make that one. Again, I'll explain what we're doing there, and everything else should be perfect as is. So just click next again. Give your car any kind of name. I'll call it Workshop DNA, and then you're done. So I'll leave it there. And then we want to go and create a new model. So in our models, we've got some default ones to work with, but I've made a few just to make sure this all works fine. If you can see this screen, you just want to hit create model, and it'll bring you to the create model screen. And from there, it's just a few options. So again, get whatever you want. This is the only required field. And I'll call it Workshop 3. Then we have our options of tracks. So as I scroll down, there's quite a few. So I'll scroll a wee bit slow just to make sure we don't, the rendering handle's okay here. But we want to choose Reinvent 2018, this guy here. It's the original track used. And it's the second simplest track to train on, but it's the most popular as well. So choose that guy and then scroll down to the bottom, and that's our own do here. And we'll click next. Cool. So you'll have your option of agents or cars, and then choose the one you've created. Workshop DNA is what I have. So maximum angle of 30, the speed gearing system of 1, and the angles at 5, and everything else should be there. Keep your time trial on the race type. Again, it's the simplest one, and just click next. And we're sticking to basically defaults throughout the workshop here just to keep things simple. So you don't have to worry about the reward function changing any of the Python code here. All you want to go down is into hyperparameters. Open this guy up. And we're just reducing the effort that the neural network needs to train itself. So choose 32 for your batch size. In your epochs, make that 3. And your discount factor, take off 2 of the 9s, just make 0.9, and change your number of experiences to 10. Don't worry about why we're doing that. As Glenn says, we'll have time to go through that while we're training. And then your maximum time, go for 15 minutes. It'll take 25 minutes for everything to go up and down, for the resources to be gathered and for the training to be finished. But that's everything there. You can untick this guy unless you want to try your hand at the wild card race. Makes no difference. It won't slow anything down really. But I would untick it just to keep things simpler. And then you're good to go. Create model. It will bring you to the training screen, and this will take 5 to 6 minutes to initialize. And I think Glenn will just go back to the slides if there's no questions or chats. Then we'll revisit this after a few slides when we see the training progress, and then from there we'll explain a bit more as well.
Yeah, sounds good. So, yeah, I mean, when you go through it that quick, it's amazing to see just how easy it is to put together. But obviously, there's a lot of a lot of stuff going on in there. So the first thing that we did really was action space. So this was when we were in the garage with the car, and we were selecting all the different parameters for the actual car itself. So the action space is basically all the different decisions that the car can make when it comes across any situation. So you can see we had a few things there like steering angle granularity, which, as the name would suggest, is how many different kind of, types of turning it can do. If it can do slight turns and heavy turns, or just like a medium turn. Maximum speed. So they've tried to keep this as close to what the actual speed would be with the physical car. And speed granularity, which you could sort of look at as the number of gears that the car has. And what this actually translates to is just a JSON array of each of these different things. So if you imagine the car, while it's training, it's trying out all these different actions when it's seeing different situations. So for example, when it comes up to a corner, the only input the car really has is its camera. So once it sees that corner coming up, it'll eventually learn that to stay on the track, it needs to take the action that turns it left, however many degrees that it needs to go. And we'll talk a little bit about the relationship with these things during the actual training, but really, if you have a smaller action space, the car is going to learn a lot quicker how to get around that track because it only has to learn how to navigate through 4 or 5 different decisions. If you have a really large action space, then it's going to take much longer for your model to actually train and learn how to drive around the track. But it does give your car more options. So you'll be able to take a better racing line, for example, if you're able to do lots of different types of turning. If you have lots of speeds available, then your car will be able to slow down going into corners and go much quicker going into straights, which again should give you faster times. So it really depends on what kind of model you're working with. And a lot of that is just trial and error, which again is why the training costs add up so quickly. The next thing that's important to look at is the reward function. So the reward function is kind of the brains of your model. And this is, it's just written in Python, and it basically is where you basically tell your car what you want it to do. And again, we'll see examples of those, but if you imagine the most basic one would just say, I want my car to stay in the center line as it goes around the track. And this is a nice, simple, kind of reliable model that will get your car around if you just keep it in the center line. So to do that, you would use these different parameters. So a really obvious one's the first one there, all wheels on track. So you would maybe say that while all the wheels are on track, your car gets some of this arbitrary reward. And we'll see what that looks like in a second. But if the wheels go off the track, then it gets a smaller reward or it gets no reward at all. And again, there are loads of these. So heading is just what angle that your car is actually facing at. Distance from object is for the object avoidance. So today we're just doing time trial, just seeing how long it takes the car to get around the track. But another part of this is obviously that you can put objects around the track and teach the car that when it approaches those objects to avoid them. Steering angle, again, is useful for if you're looking at specific tracks that you want to really tell your car that when you're coming up to this corner, you want it to have a tight steering angle. Track width is used to define when the car is in the center of the track or how close it is to the center of the track. And then waypoints is something we're going to talk about a bit more because it's such a powerful way to kind of tell your car to get around the track. Basically, as you're training it, it means that you can highlight different track features. So using the picture on your screen there, you know that when it gets to 0.7 or 0.8, that it's about to go into a hairpin turn. So you would reward the card for maybe slowing down and taking a sharp left turn. You can start playing about with actual like racing lines. So you can tell the car that when you're at this point, you have to be in this part of the track. You can be off center to the left, or you can be off center to the right. And that's really just scratching the surface. There are a ton of these different parameters that you can start playing with. One of my favorites there is crashed. So obviously you want to punish the car or never reward the car for being crashed. A few worth pointing out there. Below is crashed is left of center. And again, this is just a boolean you can like play about with to tell the car to be in like different lanes for different scenarios. What else have we? Progress. Again, we'll see an example of that being used, but with things like progress, you can just outright reward the car for making progress and let it figure out how to take different turns and when to go, in the center for straights. Objects left of center, again, is similar to left of center. For that one, you would maybe say if the object is left of center, then the car should be right of center to avoid it, things like that. And you can see waypoints heading is reversed. And again, if you have any questions about any of these, just pop them into the chat. But really, it's all about actually how these all come together into a specific reward function. So you can see this one is very similar to the default model that we actually just had in the console, the one that we're training with now. And this is just a basic centerline model. So you can see at the top there, you've got marker 1, 2, 3 are using track width to like relay back how close the car is into the center line. And then you're giving it a higher reward if it's closer to the center line. So that's that if else statement. If it's marker 1 rewards 3, you get a third of the reward if you're marker 2, and you only get like a sixth of the reward if you're marker 3. So you're still getting rewards for being on the track, but you get much higher rewards for the closer to the center of the track you are. And this fires 15 times every second as well, just to get an idea of how this is actually working. So 15 times a second, it loops around this reward function, and the car is given a reward based on what decision it makes. And then, yeah, the hands-off approach. So this is the one I was saying about where you just look at progress and also another parameter known as steps. So again, steps is how the car keeps track of how many decisions it's making. So as I said, it's about 15 per second. So what this is really saying is that you should be making a lot of progress for not very many steps. And this gets around the idea that sometimes the car will maybe like snake around the track because it's going to get more rewards overall if it's taking ages to get around the track, but it's actually taking lots and lots of steps, because for each step it's going to get some degree of reward. And this actually can be quite an effective model, though it does take a lot of time because you're not giving the car very much direction. So it has to learn everything from scratch. In contrast to that is what I like to call the micromanager, and this is using the waypoints that we were talking about earlier. So at the top of this reward function, you'll notice that we're defining all the waypoints that make up the left lane, all the waypoints where the car should be in the right lane, and then all the waypoints where the car should be in the center line. And then you're literally just going through checking which waypoint the car is actually in, and then rewarding it if it's in the correct lane for where you want to train it. And this is an incredibly powerful model or type of model, especially if you're really wanting to get good at one track. So if you're particularly racing in a virtual league and you want to really tell your car exactly where it should be at any one point in the track, this is the kind of thing you do. It's less useful for what they call sim to real, which is when you want a model that does well in virtual races, but also you can load it onto a physical car and it'll find its way around a track, simply because you're teaching it how to react to very specific situations in this. Whereas in the real world, the camera might not pick up on things exactly the way you want them to. But that's kind of its own art form. Finally, were the hyperparameters. So the hyperparameters, unlike the previous two, are more about how the car learns rather than what it learns. So it makes sense to go through these actually not in the order they are here. So I'm going to start with the last one, which is the number of experience episodes between each policy updating iteration. And you'll see a bit more about that in the actual console when we go back to it. But what this does is the car will essentially start at one point on the track. It'll drive until it either finishes one lap or goes off the track. And when it does that, that is what's called an experience episode. So you can set this from anything between 5 and 100. Obviously, the more of these that you have, then the model's going to take longer to learn because it only updates what it knows about the world and the track every however many iterations you put in here. So if you put 5, then every 5 times the car starts and stops, it'll update your model. But it won't really learn that much because there's only 5. If you set it to 100, it'll learn plenty, but it'll take ages for that to actually happen.
I can show that, Brian, while you're talking about it if you want.
Yeah, sure, yeah.
And then the hyperparameters, they'll just be at the bottom as well.
Yeah, go for it.
Cool. So yeah, you're talking about the episode stuff. Yeah, that was a really good one to start with.
Yeah, I just figure you need that description to actually describe like a handful of other ones. So you may as well start with it. Yeah, so this is actually training, and you can see that once the car goes off the track, it resets. So each one of those is an iteration, which feeds nicely into gradient descent batch size, which, if you're familiar with machine learning, is quite a generic machine learning term. This is the number of samples it takes. So every 15 times a second, it's getting a data point as to how much of a reward it's getting for taking a certain action. So there's a lot of data coming out of these. This is telling you how many batches, like random samples you take from that data to actually move forward into the next stage of your model's learning. So again, you'll probably start to see a pattern here. It's all a trade-off as to how stable your model is and how well it's learning versus how fast it's learning, which is an important trade-off whenever it's quite expensive to train these things. So again, the higher the batch size, the more stable your model, but the slower it'll learn. Number of epochs is the number of times it passes over all the data before extracting, again, these random samples, and then takes it through to the next stage. So again, the more of them, the more stable. It just takes longer. Learning rate and entropy are ones that we don't really play about with too much. But essentially, learning rate is how much they both do with the trade-off between what they call exploitation and exploration. So as the car is driving around on your screen there, it's finding a balance between trying new actions to see if it can get more points and sticking with what it knows will actually get it points. So if it sticks to the center line, it'll get more points. So I'll just keep doing that. And again, this is a trade-off that's important to how well the model will learn. If you have it tweaked too much, if you have the entropy and the learning rate tweaked too high, then the model actually doesn't learn anything new because it's just exploring all these different things instead of taking its learning through to the next thing. Similarly, if you have them too low, then the model doesn't explore and find better rewards. So it'll maybe find something that kind of just about does what you want it to, but it isn't optimized, so it doesn't actually get any better. Discount factor refers to how immediately the car is rewarded. So if you imagine the car is coming up to a corner and you have it set to be center line, say, but it's going quite quick, the car will maybe get more rewards overall over the course of that iteration if it doesn't go into the center line straight away, but it takes a good racing line that sets it up to go into the center line. Or you can say that, well, I just want you to stay in the center line, so it will maybe take that corner exactly in the center line, but it will miss out in rewards in the future because it's not set up to take the racing line that gets it back into the center. And that's what discount factor is a trade-off between. If you set it higher, then it starts favoring rewards that might happen in the future, depending on its action now. And if you set it lower, then it just looks for those immediate rewards. And again, this will depend on what type of model that you're training. But again, we'll talk about how they all tie together. And finally, loss type is to do with which of these two algorithms that, or which of these two machine learning algorithms that the model uses to learn. Generally, we don't play about with that too much. They say that if your model isn't actually converging, so if your model isn't learning how to drive, then it's worth using Huber loss just to try it out. Otherwise, mean squared is a slightly faster method of training. And this sort of stuff's covered in the documentation, which we'll give you a link to at the end. That's me for the slides for now. Darren, if you want to run through what's happening on the console.
Yeah. So, the tips that Glenn's trying to explain, or even just explanation, are in fact tips, because kind of like what we've spent so much time on is exploring these different parameters. But what you see here is a really good default set to start with. But I'll show you here before the training finishes, and then with some slides while this finishes up to go through, and I can also show the process again a wee bit simpler. This guy will go around its track 10 times, either completing a lap, which is an episode, or coming off the track, or hitting an object if you have objects or other cars. So the training graph here is really useful. To start with, it will give you your average reward, and this is just a true value returned from your reward function. So Glenn explained this guy at the start, and all it's doing is saying that depending on how close you are to the center line, you'll get a higher or lower reward. Else you'll assume we're going off, and we'll give you a reward very, very close to zero, but not exactly zero, because zero or negative really ruins the car. It thinks it has to go off the track to avoid getting that really bad reward, so it starts going off earlier to try and avoid it. So this is just what this is returning. This float reward is getting returned here per iteration. For example, it goes from 17 to 27 to 33. That's a really good general health if your reward function is good, that you're at doing what you wanted to do, either staying in the center line, going faster, making more progress. So the next one then kind of equates to that is the progress it gets around the training track. So these two together, the evaluation and the training, can be a wee bit confusing initially, but all it's showing you is the actual percentage during. And it's okay that this is low, because the car wants to try many different things, because we've set an entropy level of 0.01, saying that try these different actions, these different steering angles, these different speeds. Try 0 50 times in a row. Okay, that doesn't work. Try it with like 49 times and then 1. Maybe not as aggressive as that, but that's what it's trying to do. It doesn't know these are bad decisions, only that we're telling it so in the reward function. And that's what this is telling us. So it's okay that this is low, but as long as you see this starting to creep up a wee bit, you know that the entropy should be going down, because the car is getting more confident that it knows where to find the best rewards from. And then your evaluation is taking what it's learned after the batch size has gone through 32 times. And with that epoch, it will decide to weight afterwards against best, worst. And the evaluation is just the same as the training, and this is actually just about to finish. How far it made around the track from the point where the training finished. And that's just how something called a checkpoint file decides what iteration is the best to keep and try and improve on. So it's okay that this goes up and down too, because at this point here, it's going to try entropy of different actions. But generally, you should start to see this guy go up and up. And I have a few other examples. But generally, all these three guys you want to see starting to creep like steps. As it's training here as well, it's important to note it won't always start from the start line. It will skip across. It has an offset feature built into it by 5%. So it will start further up. If it completes a lap, it will start further from where it's continued, just so it can get more information from the track. And once this guy finishes, which it should do any minute, I'll stop it now, sure, because it's practically finished. It will enter a stopping phase, which again takes nearly 10 minutes. And when we're finished, we'll be able to download the car or the model, or submit to this community race, which I have made for us here, which I have a few examples running already. But we'll come back to this at the end. Hopefully, if you've been making a model too, it will be finished and ready to evaluate. That's really like the other two ones I have ready here if we wanted to see what 5 minutes look like. What 15 minutes look like on a different track, something just going around in an oval. Not doing too much, but even showing just the tiniest bit of progress. So 15 minutes should be somewhere in the middle, and it looks like it has done that around 62%. So for 15 minutes, that's very good. You would want to give that another hour if you could. But yeah, we can go back to slide scan and then revisit the model when it's finished.
Sure. So yeah, really, the big thing with Deep Racer is, and the reason that it's one of the reasons that it's so tough to get a really good model, is that you have to tie everything together. So it's not like there's an ideal set of hyperparameters that you could just plug in, or an ideal reward function, or an ideal action space, and then you're done. It's all about the relationship between those different things. So I mentioned how you could have a model that doesn't have any real guidance. It's just told to progress around the track. Then the hyperparameters for that model and the action space is going to be completely different to a model where you've identified all the different areas of the track that you want it to behave in different ways, like the waypoints model that I showed. Again, with action space, it has a lot to do with what kind of track you're training for. So if you have a track that's just a simple oval, then your action space is going to be much smaller than one that takes like a minute for the car to get round, that has a lot of turns. Even if you look at the example of the one that we were training on today, it only has one right turn. So in the past, you could actually go in and manually edit your action space. You could literally take away basically everything from the turning right and give it more actions of turning left, so that it can actually find a nice variety when it's taking all these left turns. Same with the oval track, it only ever turns left. So that's something that's going to be quite important depending on what track you're actually going for. Yeah, the other thing, the last point there is what I was saying about that sim to real, that if you just only ever train your car on one track, even if that's the track you're going to be doing in the real world, what the camera is seeing in the simulations, the simulated camera is seeing in the simulations, versus what the actual camera will be seeing on the day is going to be quite different. So you almost want to get your model to train on lots and lots of different tracks, so that it sees different backgrounds, and really that the only thing that it learns as a reference point is maybe those white lines in the middle of the track, or just the track itself, rather than maybe relying on like these objects that have been put into the track virtually. So again, in the example we're looking at, it's just like this plain gray background in the simulation that you can see. A lot of the other tracks tend to have maybe trees in the background or a bridge. They try to make it look like an actual Formula One track or an actual race track. One last point on that before we move on to this log analysis. If in the real world, the car can be offset by things like maybe if there's a crease on the track, or if the lighting's different from what the simulated lighting is in the simulation. A lot of that can be kind of counteracted by training it on different tracks, and again, really teaching the car to just look at the actual track for its guidance. So in the console, as Darren was saying, you can see how the model's progressing using that chart with the 3 different lines on it. If we have time, we're hopefully going to be able to run an evaluation as well. And again, it tells you, it only really tells you how fast the car is getting around the track and the percentage that it can get around the track. As I mentioned before, there's a ton of data that comes out of this stuff. And the AWS have set up a Jupyter notebook that you can pull down and like run a really detailed log analysis on it. So this is the sort of stuff you need to be doing to really get into to get into the championships really, and to get into that really like high bracket of performance. And you can see that the sort of stuff that you can get from the log analysis is incredibly useful. The first one is showing all the different tracks, all the different paths that the car took for each training iteration. So you can see if it's maybe struggling with, say, the hairpin turn on this example, and in which case that might be indicative of your action space not having a left turn sharp enough that the car can go around it, or maybe that the car's speed is set to too high and it can't actually slow down enough to get around that corner. The next one on the top right is a heat map. So it shows where the car sticks to during its training. And again, this is really useful if you want to give your car a racing line. You can actually see where on the track the car is getting its rewards. So in this case, the car is getting the most rewards if, again, using the hairpin as an example, if it sticks to the outside. But maybe you want to tweak your reward function so that it gets the rewards for clipping the inside of it and keeping a good racing line that will get it around the track quicker. The bottom left and the bottom right kind of go together, and it's showing what action the car took when it got to different parts of the track. So again, you can see the hairpins highlighted in that bottom right chart. It's the first thick red line, and you can see just which actions that it's taking at that hairpin, and you can see them actually mapped out on the track on the bottom left. We could probably do a full 2 to 3 hour workshop just on the log analysis, how to get it set up and how to read all the different charts. If again it's something you're wanting to get into, I would really recommend looking into the log analysis. It's a great introduction to Jupyter notebooks. It's it was the first time I'd seen a Jupyter notebook, to be honest, and only after the fact did I see just how useful they are in machine learning. And yeah, that's pretty much it for the slides. I'll pop this one back up at the end. This is just a series of links. But I think, can we jump back to the console at this stage?
Absolutely.
I'm also going to share, actually, so this is the AWS developer guide, which is a huge PDF. There's about 200 pages. And it covers pretty much everything that we covered in terms of hyperparameters and reward function and reward parameters that you can pop in there. But it's probably your bet. It's a great reference guide. I wouldn't recommend reading it from start to finish, but it is very useful for finding out what specific hyperparameters are, for example.
Cool. So what we have here is this guy's finishing. So what I've got set up is when your model evaluate your model, that's when you can either submit to a virtual race, which is the community race link, which I've put into the chat window here. That's free for everybody to join, and it doesn't cost anything to race on it as well. You can race multiple times. When you go down, you can choose an evaluation. So you can hit start evaluation, which I have here, and you'll want to click the same track you trained on, the reInvent 2018. Again, this will cost a wee bit. For $350 an hour, the cost of the training would maybe be 20 cents. The cost of this would probably be maybe 5 cents, because it only take 5 or 6 minutes to actually complete this. So we'll start that here, and that's just a previous one just to show what it will look like. And when this guy is finished, I will submit it in the digital DNA race. And whenever you submit, it'll look something like this. It'll give you quite a few options and details that will show you how many times you've submitted. So the first one is just the dash, just to show it's been done once. How many times it's come off the track, and how many times if it collided with anything. And then you can watch the video. Again, it's an evaluation, but it's really good just to see how well your car did. So any models you've created in 15 minutes should look something like this. It should stick to the track relatively well. Again, 20 minutes, half an hour, 1 hour, it will be even better and faster to a point, but a 1 hour would be the maximum I would recommend for something like this to see the real benefits of it.
Yeah, the other thing is it actually took us quite a long time to get to the stage where we knew the hyperparameters and the reward function and everything to actually have a model that could get round in like 10 or 15 minutes.
No, absolutely. And what I'm showing here, this is the difference between what a 15-minute model looks like, and this is a 5-minute model. So already it's almost 3 times worse. This 5-minute model just hasn't been given enough time to try a new action. So 5 minutes more rights than lefts, and it will keep going off at the start line, but it's it'll show here just in your total time the difference between the two. So it's a good example of the training effects that can take place. So yeah, this guy's still stopping, and this guy, sorry, go ahead, Glenn.
Does it, just for my own curiosity, does it eventually just stop going round once it's gone off so many times in the evaluation, or like is there an upper limit, like if it goes up 50 times?
Yeah, no, good question. As far as I know, it's the time limit is 15 minutes. If it gets to 15 minutes, it just stops. It's the same length as an evaluation period, just runs for that length of time rather than it waits for it to finish. If it finishes early, that's a termination condition. But if it runs for 15 minutes, it just stops at 15 minutes. But yeah, a 15-minute model. Yeah, it's not gonna win any prizes. So that's all for this part. I was going to go through the process slower again and explain a few decisions, and also show a wee bit about the options you have in the garage as well. And then there's a wee clip here to show a bit more about why the car is making decisions. So we've got the time to go through it, if that's okay, Glenn.
Yeah, definitely. Yeah, as I say, the slides are pretty much done. So
sweet. This guy's finished, so actually we can erase this guy, and we can use the option workshop 3, and that's all you'll need to do. Again, this is completely free. This is thing, whereas running this evaluation will cost you a few cents. This guy's free, so that's why I made the race as well. And then you actually might get a separate option there just to ask what your racer name is, which is what these guys are. And I would choose wisely if you're interested in Deep Racer, because these are set in stone for your account, which is a maybe a regrettable decision if you just went test. You'd rather maybe pick something a bit more interesting, but Debro and Newspeed, they can't ever be changed for the account. It's something Deep Racer or AWS wanted to kind of change, but they've kept it as is just to keep things simple when they monitor racers. Okay, so this guy's really, really good. Oh, if this is running, we missed it. But that's what the evaluation window looks like. It will run the same way that community race ran. It'll just give you the results back of how far it made it through the track and what time. Almost exactly the same as what you can get from here as well. It just gives you the same conditions. And you can rerun another one, and again in another 5 minutes or so. So what's going on with the reward function? When we talked about the fact that the car is taking random decisions to find the best reward, this I find is really, really useful to imagine what the car is experiencing, whereas this is the center line of the track, the orange part, and then what it's trying to do is explore where the highest rewards are. We see it easily that we want the car to stay in the center or stay in the left. Again, the agent, the car, doesn't care about any of this, because all the rewards could be full all along here until these two could be full, or this one could be full, and then this one could be the highest. It won't know until it's explored all of that. And that's kind of what you want to give it enough training time to explore. And you can see here what the car will start to do. Initially go through that and realizes that 2.2 gets me here. What happens if I mix it up and go a bit zigzaggy across the center line? But you want to start to get it the same way we've seen the graph kind of stagger. The car is actually replicating that kind of behavior as well. And just these couple of things really hit home for me whenever we were learning, trying to understand what on earth Deep Racer even was. We were trying to do virtual and Cinderreal. The virtual world was so much more different because those conditions are always constant, where it is in the physical tracks, shadows and lighting and bumps on the track. What the car sees, even though it sees it in black and white, it's completely different. You can hit very easily concepts called overfitting, which means we go through this process too many times, and all the car can really understand is the variations of the simulator. And what I mean by that is it can only ever understand that the track is perfectly shaped like this. All the walls and borders are the same shade, even though it's black and white, it'll still be different. There's a perfectly center line spacing. The thickness of these can't ever change. It's very robust in that sense that it can get really used to that, but not overtraining, not overfitting. The car will generalize these aspects, and when you take it to a real track, it won't just go off. It will start to mimic the behavior you see in the virtual world. So when we talk about overfitting, it's up and down. You can train for 20 hours and never overfit if you keep mixing up the tracks to change its kind of its aspect. You can train it for maybe 3 or 4 hours on one track and it might be okay. Really, really dependent, and that's where you can do the same process 3 or 4 times, and the model might be completely different. And you even might have the same model, run it one day, run it the next day. The different time of day, kind of the lighting that comes through in the cameras, maybe a smudge on the lens, or even how the car is calibrated physically can change so much. So you have a lot of things to be competitive, so you try and eliminate as many factors of those as you can, and that's where the log analysis can really help as well. So yeah, once it goes through, finds its best reward, there's a point wherever this graph will start to, and you can see here like these straight lines. That's the kind of aspect if the graph here was starting to overfit, where this evaluation line started to just hug along the top. It's not really learning anymore. It's maybe cementing a wee bit more what it's meant to do, but that's the kind of sign that that car is ready to be downloaded and tried, or maybe mixed up with a different track. Oh, and this is really good as well, kind of visualizing what the car is doing. So these are just like the X and Y coordinates, kind of what waypoints are being managed here. But this is like what the car actually sees to doing, because it's the front wheels that only turn, and they can turn a maximum of 30 or 0 for straight. Again, those conditions can change. What it's trying to symbolize here is, and what I wanted to kind of show is, between the action spaces that you've got for this car, you could go really, really crazy and go max and go to 4. So if you imagine all these left, and minus is right turns, and plus or positive are your left turns, by the way. So that makes it a bit simpler why we're showing all the right turns, all our straights, all our lefts. If you can imagine all of these different speeds and angles, it might try and jump from full whack at 4 meters per second going left to full whack going 30 degrees right. And if you can see it here, you could imagine like if this car was turning here, I'll not try to turn the other way, it's just going to spin, it's just going to crash. So choosing your actions wisely, you have to think as well about how hard is it for the car to change from one action to another. Otherwise, it might not have any options. It might just have to keep going straight, because that's the only way it stops it from spinning. And again, spinning will probably cause it to go off track, but that's an unusual behavior the car might not always replicate, and it might really mess it up. So that's why we were encouraging to bring it right down to like the bare minimum. You can either go left, you can go right, and you go at 1 meters per second. You can lower that down. It will train a lot better. It won't be faster, but it'll make those graphs steadier. There's a nice balance here of maybe 9 or 10 actions, and then mixing up the kind of speed you've got. Maybe something like that would be really good. It might just take a bit more training, 1 or 2 hours. But that's stuff we didn't realize at all until you maybe thought more about a real race car and how it would do its race lines, its turning. We realized that we only have these options. It can't do 20 degrees or 15, or 16 or 14. It can only do 2 types of turns, which maybe isn't enough. And different sizes of tracks and different shapes of tracks really affect that as well. So this guy got finished, so it's my new best one. So we'll give this a watch. It came off track twice. And again, sometimes you might find you race this again. It might get 30 seconds, it might get 18. So you're trying to play the odds because it's still random in nature. And what you might just notice as well is we now have like a grassy terrain. It's changed from just having a plain green back. And this can actually really affect. It's a different type of texture, so it could maybe confuse it. And what are we for time? We have a few minutes left. So I would encourage, if you wanted, race here. We haven't sorted any kind of price yet, but if we get enough racers, I know we could maybe message LAT to see if there's any kind of Amazon voucher or something like that. But I would encourage us more to be try new things. Take your model that you've made here, and maybe and we didn't mention the last part. We can now clone these models. Sorry, sometimes you have to refresh this to get these options. So it's not broken or anything. It's just it doesn't know the status has been updated from the API. So now you can download your complete model or the car model, but you can clone this. And this is another concept that was really strange, just that it will take the best learnings it's got and carry them through. Now, a few things will reset here, like your entropy. It'll go back up to the top and it'll start being random, but it won't be as random, and it will try to explore ways to get a higher reward than it did previously. So I would take your 15-minute model. You've got, Glenn, I think you said 10 hours of free training for a free tier.
Yeah.
And they'll hold true to that. Like, I wouldn't worry about any costs here initially.
It also expires after a month. So once you've done your first deep racer, then you have like a month to use those 10 hours.
Yeah, that's a really good point. So you've kind of started the clock, I guess, in that sense. You can run this, you can change anything here. I wouldn't change anything here too crazy, but if you want to, the reward function examples, any of these are really, really good to start with. Object avoidance is a wee bit trickier. Explore it if you want, but it would take a lot more training, and even me and Glenn are still figuring out the best formula for this. It's only new this year, and again, with all the summits being cancelled, no one's really had a chance to try it out too much. But untick this or ticket if you're interested. You can have a go at the wild cards and win yourself a ticket to reInvent. The prizes are pretty substantial. You get your reInvent ticket covered for next year. You don't have to win the competition at me and Glenn are, and you just have to become a participant in it. But you can clone this, keep it at 15 minutes. I would recommend maybe 30 minutes. I would also encourage, just put these guys up a wee bit. What you're trying to do is stabilize your model now. We just wanted to show something that could be done quickly. But I would maybe turn these back to the defaults they were. Maybe half them, like instead of 9, just take off 1, 9. Something like that would be really good, just to kind of show that the model won't try and learn too quickly from not trying enough options, if that makes sense. It's going to try more episodes here. It's going to have a greater sense of what it can do. It'll actually learn the limitations of its action, as well as bring it to the track and see that I will only ever do a left turn of 30 degrees here. I won't need to spend too much time learning on this. I'll focus more randomness on the rest of the track to try and stabilize better. And from there, you can just create a model, and it'll just go through the same process again, and you can keep cloning and cloning and cloning. You don't lose any neural of anything. It will just take the same amount of time to spin up SageMaker and RoboMaker. It's going to be a bit dark. Sorry, turn the light on. And what you're is just go through the same process. You can take that new model and resubmit it here. There's no issues. All that's the same process. And then when you're done, you can delete them as well if you want. I'll delete one here just to show you. There is a small cost to the storage of these models, so you can just delete it. But I mean minuscule. It's 0.023 gigabytes to the cent. So you would need a terabyte. Probably still be $10. So Generally, the sizes of these models are 300 megabytes per hour. It grows a wee bit, but 300 to 500 is what you're going to cost. So delete if you want. It's no big deal. Maybe when you're finished, delete them all, but you'll see some costs come through your bill eventually. It might be 1 cent. But again, things like that can get annoying because you may forget in a year's time what this even was or what was even was costing you. So you can delete them now if you want, or you can download them and re-import them again. That's a wee bit more time to explain, but those options are there for you as well, so you can keep it for a later day.
Should we?
That's me. Yeah.
Yeah. So just switching to our wrap-up slide. There we go. So yeah, if you want to follow us, our tags were I'll put them back on the screen. If you're interested in Liberty IT, follow us on any of our socials there. Really, they're quite active on Twitter. I think ours are on the footer of these slides. If you missed them, yeah, there we go. There are Twitter handles if you want to reach out if you have any questions or if you're interested in DeepRacer. There are all the links that I'd mentioned as well. So just to run through them really quickly, there's Liberty's Medium account. We, between us, have a couple of DeepRacer articles on there that are a good read, do I say so myself. There's our Twitters, and that's the AWS machine learning community, which is the DeepRacer community, really, that I put a link for in the chat as well. Finally, the last one is actually a little out of date. It's the how to set up the Jupyter notebooks and the log analysis that I was talking about. So some of the methods may be a bit outdated, but it really is a great article to kind of get your head around what's happening in them. And it's a good thing to start off with before going in and asking in the Slack community if you need help with anything. And that's pretty much it, I guess. Thanks very much for those who tuned in for listening. Darren, have you any final thoughts?
No, just thank everyone. And yeah, the Jupyter notebook, it's still 90% relevant. I would still visit it. It's just needs probably some tweaking, but Glenn's last point about the community, yeah, the Slack community, they're full of helpful people. But no, thank you.
Cool.
All right, everyone. Thanks again.